At the end of the last lecture, we were talking about making, oh wait, sorry, hang on. There we go. Okay. So at the end of the last lecture, we were talking about making our own classes so that we can create our own types. And we had 3 different classes. So let's just quickly review what we were doing. So we had this counter class. Oh, that's not going to let me do that. All right. So we have a counter. So this thing is supposed to be, it's supposed to represent an object that can count starting from 0 and go up to some maximum value, right? So up to integer max value in this case. Right, so we declare our class public so everybody can use it. Class name is counter, begins with a capital C, right? And it has one field, right? So every counter has one attribute or one variable, right? And that variable is called value, right? And that's just the value of of that counter, right? So it's that variable there represents the value for a particular counter object. Right? We had a point class. So this was a class that represents a 2-dimensional point having real coordinates, right? And so we decided that we're going to use 2 fields, right? Both double, so there'll be x and y. So x represents the x coordinate, y represents the y coordinate of a given point. And then we had the stopwatch class. So the stopwatch is a class where that represents a simple stopwatch, right? You can press a stop button, a start and a stop button, and it tells you how much time has elapsed since you pressed the start button. Right? And so we've decided that we're going to use some fields that represent the time. So that's the start time. And remember, we're using a method called nanotime that just returns some long value that represents the time since some arbitrary starting time. Right? So that's our start time. We have a stop time. Right? To calculate how much time has elapsed, you just take the stop time minus the start time. Right? And then we have a field called isRunning. So this is true when the stopwatch is running, and it's false if the stopwatch is not running, right? So it's true if someone has pressed start, but they haven't pressed stop, right? And it's false if someone either hasn't pressed start yet, or it's someone has pressed stop, right? Okay, so we have our 3 classes. It doesn't look like there's anything in them, right? So there's just a field. 1 field here, 2 fields here, and 3 fields here, and that's it. So it doesn't look like we should be able to do anything with this, but you can. Right? So we've got this little class here called makeSomeObjects. Right? It's got a main method in it. And it actually makes a point, a counter, and a stopwatch object. Right? And again, when you look at the classes, it doesn't look like we've done anything in them. We just have some fields. So it's surprising that this actually works. Right? So Eclipse doesn't complain about anything. Right? Nothing's underlined in orange or red. There's a little, you can't see it, but there's a little light bulb here. So the little light bulb is indicating to you that something funny is happening, right? And so Eclipse says you've got this variable called p, right? But you're not using it anywhere, right? So once we make our point, we don't use it again inside the program, right? So basically what you've done is you made an object for no reason. And Eclipse is trying to tell you that you've made an object for no reason. Maybe you should get rid of this line. Right? But we want this object to show that this actually works. So if you actually run this program, right, at the end it prints all done. It actually works. So it compiles and it runs, despite us not having done anything inside the classes yet. So that's a bit funny. Right? There's the, this is a version of the class. Right? If you run, so this, I had to change this just before the lecture started, because if you run this particular version of the program, these classes are all complete. Right? That's the complete counter class. That's the complete point class. That's the complete stopwatch class. So of course that's going to work, right? So I just copied counterpoint and stopwatch into some package and then deleted all the methods and stuff that I have in there. Okay. So everything works, but you can't do anything with the objects. So I can make the objects, but I can't use them at all, right? So if I want to use the objects, I have to add some extra features to make them more useful. Right? So for stopwatch, for example, I have to add some methods that use the fields. Right? So I want to calculate how much time has elapsed since the watch was started. Right? So in that case, I need the start time. Right? So I need a method now in order to let the user ask the stopwatch how much time has elapsed since you pressed start. Right? If I want to make some objects in a different way, instead of just using the no argument constructors, right? So for example, if I wanted to make a point 2 object with a particular x and y coordinate, I should add some features to the class that let the user do that. Right? In this case, we're going to add what's called a constructor to the class so that the user can set the coordinates of the point. Right? And so we come back to this term encapsulation, which I told you about very quickly 2 lectures ago. Right? So in object-oriented programming, that term encapsulation means bundling data, right? So the fields in this case, and the methods that use the data into a single unit. Right? So our point 2 class encapsulates the coordinates of a point, and it includes some methods that let you access those coordinates. Right? Stopwatch encapsulates the 3 fields in the stopwatch. Right? Start time, stop time is running. And it provides some methods that let you use those fields for some calculation. Okay. So the first thing we want to do is we want to add some constructors to our class. Right? Now remember what a constructor is used for. So you've used constructors. Right? Now remember that when you use a constructor, you are initializing the state of an object. Hey, can you keep it down, please? Okay, so remember that a constructor is used to initialize the state of an object, right? So in other words, what is the state of an object, right? It's just the value of its fields. So what should a constructor do? It should initialize all the fields of the object, right? And that's it. So when you create a constructor, there are certain rules that you have to follow, right? So a constructor always has the same name as the class, right? You can't change the name of the constructor. It has to have the same name as the class. Constructors never return a value not even void, right? So you can't have any return type on a constructor. Constructors are allowed to have 0 or more parameters, right? So there's no return type, but otherwise it looks like a method, right? So you can have parameters which will accept arguments to the constructor. Okay. Now remember, whenever you make an object, right? So whenever you use that new operator, right, that's always followed by a constructor call, right? So in this case, we're calling the no argument constructor for point 2. Right? Here, we're calling the no argument constructor for counter. There, we're calling the no argument constructor for stopwatch. Right? So whenever you use new, there's always a constructor call. But our classes have no constructors, right? There's nothing inside the counter class except the field. Right? So the rule in Java is if a class defines no constructors, right, then the Java compiler silently inserts the no argument constructor for you. Right? So in other words, in our example here, right, we have no constructor for the counter class. So when the Java compiler compiles the counter class, it automatically inserts a constructor for you. Right? That particular the compiler synthesized constructor sets the fields to some well-defined values. Right? So it turns out in Java, if you have a primitive type field, it gets set to 0. If it's Boolean, it gets set to false. If it's a reference type, it gets set to the value called null, which means no object. Right? So the no argument constructor in this case makes a counter whose value is 0. Right? For point 2, it creates a point whose coordinates are 0 and 0. And for stopwatch, it creates a stopwatch whose start time and stop time are 0 and is running is false. Right? So that's the one you get automatically if you don't declare any constructors. Right? Now, the problem is when you make a class, you normally want to have more than one constructor. It's usually the case where you have more than one constructor. Right? So as soon as you define any constructors, the compiler no longer makes the no argument constructor for you, which means normally you have to define it yourself. Right? So the no argument constructor, it's the constructor that has no parameters. Right? The purpose of the no argument constructor is to initialize the state to some default value chosen by you, the programmer. Right? So as the implementer of the class, you're allowed to decide what does the no argument constructor do. Right? Of course, you're going to tell people what it does when you document your method. But otherwise, it's up to you. Right? So here is where I tell you what the compiler-generated no argument constructor does. Right? OK, so for the point 2 class, I'm going to have several different constructors that means I have to define my own no argument constructor if I want one, right? And so I'm going to decide to make the no argument constructor should initialize the point to 0, 0, right? So it's very easy to implement this constructor. It just looks like this, right? So name of the constructor, same as the name of the class, right? No return value, right? You can choose to make the constructor public, protected, package private, or private, right? In this case, I want everybody to use it, so I'm going to make it public, right? Now, I'm going to set x to 0, and I'm going to set y to 0, right? But I'm going to use this slightly funny syntax to do so, right? So I'm going to write this x equals 0, and I'm going to write this y equals 0, right? It turns out you don't have to write this, but I will always write this in front of a field. Right? So in front of every for every non-static field, right? So x is not static in this case, right? Y is not static, right? So for every time I use a non-static field, I'm going to write this dot in front of it. Okay? You don't have to, but I encourage you to do so. So what does the word this mean? Right? So the word that, has anybody here programmed Python? Programmed a class in Python? Anybody? You have? Yes? Yeah, have you made your own class in Python? Yes, no? Probably not if you've just taken 121. Yes? Sorry? You've done a little bit? Okay, so when you make a class in Python, there's always this other funny parameter kicking around called self, right? Okay, so self in Python is the same as this in Java, right? If you don't know what self means in Python, just remember what this means in Java. So the keyword this in Java means inside a constructor. So this is a reference to the object that's being initialized, right? So this is a reference to the object that's being initialized, right? So in other words, when we do something like the following, right? So when I say new point 2, right? Remember what this does. New makes memory for a point 2 object, right? So an object gets created in memory, right? That constructor fills in the fields of that object that was just created, right? So the reference to the object that was just created is called this inside of a constructor, right? So that's the way that the Java virtual machine knows which object it should be initializing, right? Because it actually gets a reference to that object. Okay, is that clear to everybody? Any questions? All right, so that's actually quite important, the way that this works, right? And so there's no parameter here, right, inside the brackets called this, right? This you get for free inside the constructor, right? So in other words, the constructor automatically creates a parameter called this, right? And when the constructor is called, the value of this is automatically set to the object that is being created. Right? So this dot y means set the y coordinate of the point that's currently being initialized, right? This dot x means set the x coordinate of the point that's currently being initialized. Right? So this is a picture of what happens. So I make a point 2 object using new and calling a constructor, right? So there's my variable p, right? Point 2p. There's p sitting in memory somewhere, right? So a reference variable called p is created somewhere in memory. New allocates memory for that point 2 object. So point 2 object appears somewhere in memory, right? It can appear anywhere, right? As long as where it appears is empty, right? So our point 2 object appears somewhere, right? Every point 2 object is just a copy of the class, right? So what does the class have? Well, it's got a field called x. It's got a field called y, right? So those fields automatically appear in memory as well, right? So now the point 2 constructor runs, right? So new makes the object. The point 2 constructor fills in the fields of the object, right? The point 2 constructor gets the address of the object that's being created, right? So it gets the address 600, right? And that address is stored in the variable called this, in the parameter called this, sorry. Right? Right? So here's the point 2 constructor running in memory, right? So every time a constructor or a method runs, right, it runs somewhere in memory. Right? So the constructor appears in memory somewhere, right? It has a parameter called this, right? That automatically gets filled in to the object, to the address of the object that was just created, right? So this constructor knows which object should it be filling in the fields for, right? So the constructor now runs, right? What does the constructor do? It's this dot x equals 0, this dot y equals 0. So what's this? Well, this is the object at address 600. What's this dot x? Well, it's that x, right? And what's this dot y? Well, it's that y, right? So those values get filled into 0. Yep, and then the value of p, right? So finally, everything on the right-hand side is now done, right? The constructor's done, new is done, right? So this value here becomes the address of the object that was just created, right? And so now p refers to the object at address 600, right? That constructor now goes away, so whatever memory is associated with that constructor disappears, right? The object sticks around, right? It would be bad if the object disappeared too, because he just made one, right? So the object sticks around, right? So is that clear to everybody? Right? So that one little line of code does a whole lot of stuff in Java. Right? It does a lot of stuff, and that's similar. This is similar to what happens in Python when you make a new object for the first time. Right? A constructor gets called. Sorry, memory gets allocated for the object. A constructor gets called to fill in the fields of the object, and then the address of a reference to the object is stored in the variable on the left-hand side. Right? So the exact same stuff happens in Python. All right, clear? Good. Okay, so what about the counter class, right? So if I want to make a no argument constructor for the counter class, what should it do? Well, the documentation for the class says the counter is going to start counting from 0, right? So it makes sense for the no argument counter, for the no argument constructor to initialize its count to 0. Dead easy, right? This dot value, this dot value equals 0, right? One more time, what happens, right? So when you write that, right, a variable c gets created somewhere in memory, right? New runs, so a counter object appears, right? The counter object is just a copy of the class, right? Our class has a field called value, so the field called value appears in memory, right? The constructor now runs, right? So when a constructor runs, it takes room in memory, so it appears somewhere, right? Inside the constructor, it has a parameter called this that's set to the address of the object that was just created by new, right? So it's set to the address 550, right? Constructor runs, setting the value, this dot value, right? So this up here, dot value right there to 0, right? And now that address here gets returned back and set to C. Gets stored in C. Right? So it's always the same sequence of steps that happens when you create when you create an object using new. Okay, for the stopwatch, we're going to decide to set the start time to 0, the stop time to 0, and the stopwatch is not running. Right? So again, dead easy. Right? Start time is 0. If you want a long value, you can put L after the integer. Right? So little l or capital L. You should use capital L because little l looks like 1. Right? So 0 big L means the long value 0. Stop time is also going to be 0, and the is running will be false. Right? And that's it. Okay, so no picture here because it's the exact same steps as with the point to and for counter. Okay, so we now got one constructor in our class. We can add more later, right? We can now add some methods to our class so that our objects can actually do some computation, right? So the purpose of a method is to perform some computation, right? Normally the computation involves the fields of the object. Right? Not always, but normally that's what happens. Right? So when you make all of our methods in the class so far have been static. Right? Now it turns out a static method can only access the static fields of a class. Right? Our fields in our classes are not static. Right? So if you go back to the counter class, right, that field is not static. So I'll tell you what a static field means a little bit later on. But for now, that field's not static. So it turns out a static method cannot use that field. Right? Oh, sorry. So if you have a non-static method, right, then a non-static method is allowed to use any field belonging to the object in the method. Right? So for example, we can provide a non-static method that allows the user of the class to set both the x and y coordinates of a point. Right? So here's a method called set. Right? Ignore the return type for now. Right? It's public, The method's called set, right? It's got two parameters, new x and new y, right? So when the user calls this method, they can provide a new x coordinate and a new y coordinate, right? So what should that do? Well, it should change the x and y coordinate of the point that was used to call the method, right? So inside of a method, the keyword this refers to the object that was used to call the method, right? So this is a non-static method, so you need an object reference to call the method, right? So I need a point2 object p to call this method. When I call the method, I write p.set, some value, right? Inside the method, the keyword this is the address of p in this example, right? It's the address of the object that was used to call the method. Why do we need the address of the object that was used to call the method? Because I need to know which x coordinate to point, right? I need to know which object's x coordinate to change. And I need to know which object's y coordinate to change, right? So I need the address of the object that was used to call the method, right? So to change the x coordinate of the point, it's just this x equals new x and this y equals new y, right? Now this method is a little funny. So it returns a reference to a point2 object, right? And if you look at the documentation, right, you see that there is this thing that says @return, right? It says it returns a reference to this point, right? So if you want to return a reference to the object, you just write return this, right? Now the reason you might want to do that, so in this case you do want to do that, is because of the way that someone might be using, that the user is probably going to use the point2 class. Right? So when you return a reference to the object, you can chain method calls together, which is handy. Right? So it's not handy for all classes. It's handy for classes that represent mathematical objects like points. Right? So if I have a point p, I can write p set new, well, let me just write in some numbers here. So minus 1.5, 2.5. Right? Now that set method returns a reference to p. Right? So that actually results, the value of that is a point2 object, is a point2 reference, sorry. Right? So that's actually the point2 object p, which means I can now write dot some other method. Right? And if some other method returns a reference to p, I can write dot some other method, right? Dot some other method, dot some other method. So you can chain a whole bunch of method calls together. For mathematical objects, this is useful because you can do things like p dot add something, multiply by something, then divide by something, right? For most, for many other types of objects, this is not so useful. But for mathematical objects, it turns out this is handy, right? So that's a neat little trick that you never get shown in most introductory programming courses. Okay. Now you're allowed to add as many methods as you like to a class, right? So I can add a method that lets the user simply change the x coordinate, right? So not both the x and y, but just the x, right? So I can have a method called x, right? It takes in one double value as its parameter, right? And it changes the x coordinate of the point. So how do I change the x coordinate of the point? Well, I set this dot x to equal the new x coordinate. Right? Same deal here. I'm going to return a reference to the point in this case, in this example, because it's often useful to chain method calls together. Right? So again, return this returns a reference to the object that was used to call the method. Right? And you can keep on going, right? So now I can provide a method that lets the user change the y coordinate. It's going to look exactly the same as the previous one, right? So it's called y, right? Takes in one parameter, that's a double, right? Which is the new y coordinate. This dot y equals new y, and in this case, return this. And you can keep on going, right? So you can keep on adding method after method after method. Okay, so you'll sometimes see the term called mutator method, or mutator method in object-oriented programming. So a method that changes the state of an object is called a mutator method, right? So mutates the object or changes the state of the object, right? So set x and y, those are all examples of mutator methods, right? Because they all change the coordinates of a point. An accessor method is a method that does not change the state of a point, right? So instead, it returns some information about the state of an object. Right? So it doesn't change the state, returns information about the state. So for example, if someone's using a point2 object, they probably at some point are going to want to know what is the x coordinate of this point. Right? So you can give them a method that returns the x coordinate of the point. And I can even call it the same name as another method in the class. Right? So here I've got a method called x. It has no parameters. Right? Back here we had a method called x. It had one parameter. So as far as Java is concerned, these are two different methods. They have the same name, right? But they have different parameter lists. So they are allowed to exist in the class at the same time. Right? So there's our method x, no arguments. This time it returns a double value. Right? What does it return? It returns the x coordinate of the point that was used to call the method. Right? So what's the point that was used to call the method? Well, it's this. Right? So you return this dot x. Right? It turns out that you are allowed to leave out the this. Right? So you could just write return x, and the compiler silently inserts the this dot for you. Right? I would encourage you, if you haven't done any object-oriented programming, that when you use a field, write this dot in front of it. Right? Because that will make it clear that you're referring to a field instead of a local variable or a parameter of the method. Right? Similarly, I can return the y coordinate of the point. Right? So method's called y, has no arguments, so it's different than the other method called y in the class. Right? And it returns the value of the y coordinate. Okay. So the first line of a method declaration is sometimes called the method header. Right? So in other words, that, right, is called the method header. So a method header is made up of the following parts. It's got some modifiers, then it has a return type, then it has the method name, then it has a parameter list. Right? And then there can be a throws clause if the method throws what's called a checked exception. So I'm going to ignore 5 for now. Right? If I remember, we'll come back to it at some point, but for now we'll leave that out. Okay, so what's our set method header look like? Right? So there's the set method. Right? The header is the entire line. Right? The stuff in the front, those are the modifiers. Right? So in this case, we have one modifier, public. Right? That means anybody can use the method. Right? Then there's a return type. So in this case, the return type for this method is a point2 reference. Right? Then there's a name. Right? And then there's the parameter list. Okay, the parameter list is the list of types and names that appear inside the round brackets. Right? So inside those round brackets, right, the names of the parameters have to be unique. Right? So now I can't have two parameters called x. Right? The parameters, they become local variables for the method. Right? So this method says there's a local variable called x, there's a local variable called y. Right? The names x and y are usable inside the set method. I think on the previous slide it's new x and new y, but it doesn't matter in this case. Right. Okay, now there's something called the method signature. And the signature consists of the method name and the types in the parameter list, right, in the order that they appear. Right? So in other words, the names of the parameters are not part of the signature. The return type is not part of the signature either, which confuses a lot of people. Right? So the signature of the set method is set double double. Right? So there's a bunch of other examples that we can look at in order to make sure that this is clear to you. Right? So there's a method called toUpperCase in the string class. Right? Its signature is just toUpperCase. Right? CharAt, its signature is CharAtInt, right? Because it only has one parameter whose type is int. Right? IndexOf, its signature is IndexOf, and then string, and then int. Right? So right there. And then getChars, its signature is getChars, int, array of char, int. Right? So there are more examples of signatures. It's very easy to determine the signature of a method. Now why am I telling you about this? Because the method signatures in a class must be unique. Right? So you can have as many methods as you want that have the same name as long as the signatures of the methods are all different. Right? So if I wanted to, right, I could introduce another method to the class called set. Right? Now remember, we have one that's set double double. So I'm allowed to create a method called set with one parameter double. Right? So the set method, I'm going to pretend set x changes the x coordinate of a point. Right? And I guess in this case, it's sort of implying that it sets the y coordinate to 0. Right? I guess you could implement it so that it leaves the y coordinate unchanged, but it doesn't matter. Right? So I can introduce this method called set that changes the x coordinate, but I cannot introduce both of these methods. Right? So I cannot introduce a second method, I guess a third method called set, that changes the y coordinate. Right? Why? Because these two methods have the same signature. Right? So when you try to call this method, there's no way for the compiler to figure out which method do you mean. Right? The parameter name does not affect the signature. Right? So two methods with the same name but different signatures are said to be overloaded. Right? I don't know if that's so that's definitely the term that Java uses. It's the term that C++ uses. I don't know if that's the general object-oriented term for it or not. Right? So I can add a method called distance2 that computes the distance to another point, right? The distance between a point and another point, right? So I can compute the distance to another point whose coordinates are given by two floats, right? In the same class, I can have a method called distance2 that computes the distance to another point whose coordinates are given by two doubles. And I can have a third method called distance2 that computes the distance to another point p, where that point p is given by a point 2 reference. Right? So those can all legally appear in the same program. Right? Sorry, in the same class. Right? And those are all examples of overloaded methods. Right? Same name, different parameter lists or different signatures. Right? And you can keep on going. So you can have distance2 float double, distance2 double float, distance2 int, et cetera, et cetera, et cetera. Right? As long as the signatures are different, they can exist in the same class. Okay, in Java, a method must return a value. Right? So unlike constructors, which never return a value, methods always return a value. If they return nothing, then the type is void. Right? So if you have a method that does not return a value, you have to put in the keyword void as the return type. Right? Unfortunately, in Java, a Java method can only return a single type of value. Right? You can only return one value from a method, which is super inconvenient if you come from Python. Right? Because from Python, you can return a tuple, which means you can return as many values as you want, which is really handy. In Java, you can't do so. Right? Only return a single value. So the method public double x has a return type of double. Right? Okay, there are methods that are common to all classes, even the ones that you create. Right? So in Java, every class is actually what's called a child class of this thing called object, right? So big O object, which is defined in the package java.lang. Right? Don't worry about what this term child class means. We're going to talk about that, I guess, in week 6 or 7 of the course. 7 or 8 of the course. Right? But what this means is every class, including the ones you create, they get all of the methods that are defined in this class called object. Right? So when you make a class, you get a bunch of methods for free. The ones that you get for free are the ones that are defined here. Right? So in other words, the methods that you get for free are common to every object that you create in Java. Right? So there's actually 11 of these methods, but we don't really care about all 11 of them. The 3 that we care about are these ones right here. Right? So there's a method called toString, which returns a string representation of your object. There's a method called equals, which lets you test are two objects equal. And there's a method called hashcode that I'll explain to you later on. Right? So those are the 3 that we want to look at. Okay, so toString is a handy method because it lets you print an object. Right? So toString is supposed to return a textual representation of an object. Right? It's up to you to decide what does that textual representation look like. Right? So for a point P, we're going to decide that it looks like round bracket, x coordinate, comma, space, y coordinate, round bracket. Right? So that looks like a point that a mathematician might write. Right? You can decide to make it something else. Right? You could use square brackets. right? You could use squiggly brackets. You can write x equals -1, y equals 1.5, or whatever you want, right? I've decided that toString should return a string that looks like that. Right? Okay, so when you implement toString, right? Sorry, so you can put into your class a method called toString that returns a string object. That is the textual representation of your object, right? Now, I told you that you get a version of toString from big O object, right? And that's actually true, so that's good. So let's do that here. Okay, so here's our .2 object, right? If I look at our .2 implementation, there's nothing in it, right? So if I print that object, like so. Whoa, sorry, print line p to string, like that, right? Notice that, again, Eclipse does not indicate that there's any error, right? It's perfectly happy with this line of code. And so what that means is our .p really does have a toString method, even though we haven't defined one yet, right? So that method comes from the class big O object, right? Okay, does this run? Yes, it runs. Does it print out anything sensible? No, it prints out something very strange, right? And so what happens if you just use the object version of toString, right? You get the fully qualified name of the class, right? Followed by an @ followed by some funny number and some symbols, right? So this is not a very useful textual representation of a point. I think we'll all agree, right? Yes, I can tell it's a .2 object. I have no idea what its coordinates are, right? And I've got this funny thing at the end, and I have no idea what this means, right? I don't know. Well, you can look. If you look in the object class, you can see if it tells you what that funny symbol there means, right? But I think we'll all agree this is not a very useful implementation of toString. So what you're allowed to do is you're allowed to replace the implementation of toString. Oh, sorry. Right? And so the way you replace an implementation of an existing method, right, is you just redeclare the method in your class, right? So I declare the method as public string toString. So it has to have this, it has to look like this. The header has to be this, right? And I've got this funny @override thing here, which I'll explain in a second, right? What should toString do? Well, I want the string representation of my point, right? I've decided that it's going to be round bracket x coordinate comma space y coordinate round bracket, right? So how do I make that string? Well, it's round bracket x coordinate comma space y coordinate round bracket, right? And that's it, right? So that gives you the string representation of your point, right? And then we just return that string, right? So yeah.
Why do you have to use toString? Why can't you just say system.out.print and then this.x, this.y?
Okay, so that's a good question, actually. So the question is why don't we do this? So instead of doing p toString, right, we're going to do p. Actually, I can't get x and y yet. Okay, so because I don't have that in my class. So the question was, instead of using toString, why don't I just manually call the x and y methods from the class and print out the x and y coordinates, right? The answer is because that's a pain in the butt, right? It's much easier to write p toString, or it's even easier, you can just write p, right? So if you write that, you still get the same output. So it's way easier to write that than it is to manually call methods every time you need to print an object, right? Especially if your object has a very complicated state. And then trying to print out that, so imagine trying to print out a list of 100 objects, a list having 100 elements, right? You'd have to call get 100 times, right? You'd have to put it in a loop and then print, right? That's a pain in the butt. If you could just write system.out.println my list, that would be way easier, right? And you can do that for a list, right? Oh, so what happens here? So why does this work? It works because println, that method there, if you look at its implementation, if it sees an object, it automatically calls toString on the object, right? Why does that work? Because every object has a toString method, right? So you don't have to put in the toString here manually yourself, right? Println is smart enough to know to call toString for you if you don't do it yourself. Right? Okay, what is that funny at override, and do I need it? Right? So what is that funny? So the answer is no, you don't need it. Right? When can you put it in? So you can put in at override when you are replacing one of the methods that you got from object. Right? So I know that there's a toString method in object. I would like to replace it, so I'm allowed to put that in. Right? If you change, here, let me show you an Eclipse. Okay, so let's put in our toString method here. So public string toString. Whoop. So I'm just going to return the empty string for now. Okay, so that's perfectly fine the way it's written, right? If I want to, I'm allowed to add at override, right? And Eclipse is still happy with it, right? Now what does at override do? It actually checks, did you type in all of that correctly? Right? So in other words, it checks, is there a method in object that is public, returns a string, and is called toString? Right? If you accidentally misspell your method, right? So I change it to lowercase, right? Notice that Eclipse automatically underlines it in red, right? The only reason it's underlining it in red is because you asked the compiler to check that this is in fact, you are in fact replacing an existing method, right? If I get rid of that, that line in red disappears, right? So what does this say you're doing? Well, I'm making a method called toString, right? So as far as Java is concerned, this is just another method that has a funny name, that has the name toString, right? It's not the same toString as the one that I got from object. Right? So if I save that and run my little program here again, you're still going to get the funny output here. Right? So this one is using the object version of toString. Right? Whereas here, you almost certainly meant to do that. Right? You know what? Why don't we just quickly put this in? So bear with me for 1 second. This dot x, whoops, sorry, plus comma space, plus round bracket. Is that, oh wait, the y coordinate, plus this dot y plus, there we go. Okay, so when I fix that up and run this, whoop, there you go, right? So now you actually get 0, 0. Right? If I put back in the at override, right? Everybody's happy, right? So the compiler does not indicate to you that there's an error, so that means I have in fact replaced an existing method. Right? Now, what happens if you try to use at override on a method like x? Right? So return this dot x. Right? So there's my method, everything looks fine. If I put at override in front of this, right, it's going to complain. Right? So if you hover over the error, it says the method x of type .2 must override or implement a supertype method. It's trying to tell you there's no method in object called x, right? So you can't override that method, right? So you have to get rid of that, and now away you go, right? So you only put in that tag. This is called an annotation in Java. So you only put in this annotation if you are in fact trying to replace an existing method from object. All right, any questions about that? Super, what do we got? toString. Oh, here we go. Okay, so now I can make a point, I can change its coordinates, I can print the point using toString, right? If you want to, oh wait, you can just write p here, right? And you probably should just write p here, right? So the toString method is very useful, especially to new programmers, right? Where it's often useful to print out stuff so that you can debug or trace through your program, right? It's very handy to put in a toString method. All right, let's leave it there and see you after reading week.